Let's get started. For this Kong Tech Talk, our wonderful senior field engineer turned developer advocate, Kat Morgan, will give you a guide to selecting the best Kong features for you and your use case, including what Kong looks like on Kubernetes, the microservice components that make up the Kong gateway, and how they fit into a real-world use case. So with that, I will hand it over to Kat to get this started. Thank you, Kat.
Thanks, Taryn. All right, so Taryn covered it really well. Today we're going to dive into unwrapping what is Kong Gateway. What all do we put underneath that product label? Because there's a lot of different components that we tie into serving that entire API gateway business need. So we're going to go ahead and review quickly what the differences are between open source, enterprise, and enterprise free. Then we're going to go into some discussion about how to decide what you actually need for your organization and what choices you can make if you are or are not going to leverage all of the features that come with the API Gateway product. And then we'll take a look at a little bit of an example scenario that I brought with me today from my time in the field, so that you can kind of see how an early adoption phase of Kong Gateway in a production environment might look in a real world example, including a custom plugin and some other integration. So like Taryn said, I will be pausing for questions intermittently. There will be a slide prompting for that. Feel free to queue your questions in the chat in the meantime, or to wait until those prompts and drop them, and we'll spend a little bit of time throughout answering those. And then at the end, we'll stop again. We'll summarize, make sure that any remaining questions are answered, and the time will be yours to fire any questions towards me that you might have lingering in your head at that point. So without any further ado, let's go ahead and get started. And if my shortcuts will work. Okay. So the Kong Gateway releases include the open source version, an enterprise free version, and an enterprise paid version. So obviously the open source is the open core of the Kong API Gateway, and that provides all of the features required to be the best in the game for serving traffic and making sure that your customers can reach your application in a resilient, reliable, and low latency way. The enterprise product expands on that by wrapping that core access and traffic handling ability in enterprise features that include role-based access, web UIs for management and observability, and integrations into other things such as OIDC and for authentication, or different access control methods and traffic handling, proxying, and caching type integrations. The enterprise free and enterprise paid are different. So if you use the enterprise product, that is that proprietary compiled Kong product, the enterprise free will be quickly observably different with the addition of a read-only web UI. And then the enterprise paid, where you actually take that product and enable the license on it, is when you get access to all of the additional plugins and integrations that that enterprise license entitles you to. So, but functionally otherwise, the enterprise free is the same as the open source core. So the components we're going to get into today are going to include the data plane, which is the actual proxy component, the control plane, which is a few different pieces, wraps a few different pieces. That is the Admin API, the Admin GUI, and the Ingress Controller. Ingress Controller is specific to, obviously, a Kubernetes deployment. You may be aware that there are many different ways to install Kong. We'll get into that. We're going to jump into a little bit about the developer portal, the future operator, the Kong operator, plugin options, and some of the dependencies that you may use when deploying a Kubernetes Kong gateway. All right. So, as I mentioned, there are a lot of different modes of installing Kong Gateway. The history of Kong Gateway originates before Kubernetes really came into public view, let alone common production usage. So with that heritage, we have maintained the ability of Kong to operate either in Kubernetes in its containerized, container native format, or outside of Kubernetes. If you want to run it in EC2, on bare metal, so on and so forth, you have typical RPM and deb packages. There are tarballs if you want to go the classic Linux install route. And then besides that, you can also take the Kong containers and run them outside of Kubernetes, whether that's going to be Docker Compose, Docker Swarm. You might have an interest in ECS or Fargate, and those are all supported by Kong based on its full capability for different paradigms. So you can start to imagine that all of the bells and whistles that you have to control when designing and deploying Kong before even getting into that day-to-day operation, with all those different topologies and all of the different components of the product that you can choose from, it does start feeling a little bit like an airplane cockpit. There's a lot that you can possibly deal with. So let's try and simplify that just a little bit. So the open source product, as I mentioned, that is that core proxy feature that is going to make sure that the traffic reaching your service, your products, is going to be that core Kong capability. You're going to manage it with the Admin API or Kubernetes resources. And that does include the Ingress Controller and a suite of the free plugins and the ability to add and develop your own custom plugins. Plugins right now are developed in Lua. And that is the core, that Kong open core. Additionally, once you jump to the enterprise free, which is that open core wrapped in the enterprise product, that's when the admin GUI can come online. That is configurable in the Helm chart or with the config variables or environment variables that can be used to configure the Kong gateway if you are not running in Kubernetes. And then the enterprise licensed Kong gateway, when you actually go ahead and feed that license entitlement to it, that is where you're going to see that's where you're going to see all the plugins enabled. So there are the licensed tier plugins. Multiple workspaces is actually a really neat feature that when I was first learning Kong, I was underrated in my mind. The vitals for built-in monitoring and alerting. RBAC, that is when you get to start segmenting the administrators and the developer teams that have access to Kong Gateway for configuring it, whether or not they're using Kubernetes objects, YAML applied to the Kube API, or whether they are calling the Admin API directly. And then, of course, that is when the Admin GUI goes from read-only to read-write. One privilege without RBAC is you open up the ability to configure Kong and still control who can do what with your Kong gateway. And it gives you per workspace developer portals. So the developer portal is going to be a place where you can document your APIs. Generally speaking, when you're serving APIs publicly, you're going to want to be able to teach your user base and developers that might want to execute against your APIs what the available schemas are, how to use them, and the developer API GUI is a great place to do that. And we have several customers who have completely themed it so that it is part of their brand and a core component of their entire product offering. So the many platforms that we can support with Kong Gateway, like I said, there's bare metal VM instances, Kubernetes, we can see the containers going all kinds of places. And then there is also the Connect Cloud. That is the Kong hosted control plane where we maintain all of the liability for operating and running your control plane, maintaining the health of the state, that database that backs up your RBAC features. And then you run the data plane, which is the proxy component on your own, in your own environments, whether that is on AWS or whether that is on other public clouds or in your own data centers. All right, so how do you choose what you are actually going to try and leverage when attempting to design your Kong Gateway adoption? And an adoption might be a journey. So you might start off with a core set of the Kong Gateway features and then plan a roadmap that spans months or a year or two, depending on how your organization has been practicing production, whether it's already container native or if you are just at the beginning of your container native journey. All of these things can weigh in to how you choose to adopt the features that are available by Kong. If you are already leveraging different RBAC schemes at the API level, say your developers wrote product X and it's maybe a pet store, and your pet store has RBAC so that your users can log in and have accounts and all of those things. That type of functionality might already exist in your application. And in a lot of scenarios, that is coded into the application itself. One of the reasons that Kong Gateway improves a production environment is because it takes the onus of those kinds of role-based access controls and brings it up over to the gateway level. So that frees up your developers to just develop the core features and functionality of the product without having to bear the burden of maintaining RBAC and things like that as well on every single application or maintaining their own controller. So, and that would be one thing that we think of when we talk about integration. Do we integrate with Okta? Do we integrate with other OIDC providers? Do we have our own APIs that add context and information to requests that are in transit? Those are things that we talk about when we're considering the overall integration of the Kong Gateway. So That is a key thing. When you're trying to design for the outcome, the business value that you're looking for, it's important to weigh that end result that you're looking for. Then once you have kind of scoped in where you're aiming to go with your Kong Gateway adoption or enhancement, it's always a question of how much time do you have and how much can you invest financially into this adoption journey or enhancement journey. So, and that's where we look at, things like the labor required for deployment and for developing plugins and for integrating into existing or solutions that you already have, or replacing the burden of implementations that you have with Kong's built-in functionality, or how much can you afford to bolt on the entitlements that allow Kong to deliver these other functionalities for you. And in the end, it always comes down to choose wisely. You have to choose wisely between whether or not you are going to be primarily achieving the goal with labor or cost, and how far you're going to carry that integration to free up developer resources to iterate on features rather than just keeping the lights on with your different authentication and caching and security measures. So we're going to get into some more details. But with that, I did want to go ahead and pause for just a second in case there are any questions. And I'm going to let those roll in for just a second. Taryn, I don't know if you see anything coming in.
No questions quite yet, but if y'all have any questions, feel free and enter them in. We're a small group today, so enter them in the chat or in the Q&A, and we'll wait just another few seconds to see if anyone has one before Kat continues. Going once, going twice. Okay, you can go ahead and keep going, Kat. Thank you.
So let's dive into the component architecture with a visual representation here. You'll notice on the left that I am primarily looking at the control plane aspects of the Kong Gateway. There in the center, obviously the core value of Kong is that proxying capability, and that is what we're representing on this diagram here. And then on the right, we're looking at the integrations. So if you are leveraging a Redis database, for example, for caching across your different Kong proxy data plane instances, whether you are integrating into different OIDC providers or coding or utilizing other plugins yourself. So starting from the top, on the left side of this diagram, we have that developer portal. And we went into detail about that well enough. So let's move on to the admin GUI. The admin web UI is a visual representation and interactive model for observing and managing the configuration of Kong. So if you are looking at services and routes in Kong Gateway, those are the definitions that determine how the data plane proxy is going to respond to requests coming in the door and how it communicates to services upstream that it is proxying that traffic to. And behind that web UI is the admin API. You can call the admin API directly with things like Insomnia or Postman. You can use curl, or Deck is a declarative tool if you're not on Kubernetes and you want to use a declarative API GitOps style workflow. The Deck CLI is available for that. And both the developer portal and admin GUI have the option of running DB lists, and you'll hear that thrown around. DB list is going to be a use case where you do not need RBAC. You are probably at that point running a GitOps workflow, and Git is going to serve as your RBAC point of control at that point. If you're using the full DB full Kong gateway deployment, that is going to be what actually controls who can access what workspaces you have, and it maintains the state for that across both the admin and the developer sides of the product. Another bolt-on that you probably leverage if you are Kubernetes native is the Ingress Controller. So if you think about the Kong Admin API and the different methods of interacting with that, you can use the curl commands directly to configure it, which is a little bit long in the tooth, or you can use things like deck and the admin web UI. The Ingress Controller is basically a replacement for those interfaces and allows you to define all of the typical Kong gateway functions with Kubernetes manifests. The CRDs, the custom resource definitions, are the Kubernetes language that you're probably accustomed to seeing in YAML files, which describe all of that configuration. When those YAML files are applied to the Kubernetes API, the Ingress Controller receives that state by reading the Kube API and applies that in a push model to the Kong Admin API with Kong native configuration. So it's basically an interpreter at that point between the Kube API and the Kong API. Now, all of these configuration details have to get to the Kong data plane somehow. In the Kong gateway design, that is a push model. So the proxy containers sit there in your Kubernetes production or in your EC2, and they are operating based on the latest configuration that they have. If there is an update, the admin API will push that down to the Kong data planes that are listening for that configuration. And that is where the new config will roll out. That happens without interruption of traffic. So if you are running a production, you will not be seeing the pods dying out. Those pods stay alive during this entire configuration change. There are times when the Kong gateway pods may actually roll. That's where you see them terminating and being replaced with new pods. If you have specific certificate changes that are specific to the Kong services themselves, the default certificate, for example, or other secrets that are injected into the data plane containers, that's when you'll actually see the Kong gateway data plane pods rolling. And then as far as uptime goes with that, that's when you will want something like a load balancer in between your data plane pods and your public traffic. And then the integration pieces, things like Redis or some of your custom plugins. If you update a custom plugin with new plugin code, that is going to cause your data plane proxies to roll so that you have new containers replacing the existing containers. If you update the configuration of a plugin but don't change the actual plugin code itself, that is going to be an instance where normally the admin API is just going to push that new config out and your existing proxies will continue to run without replacement. One thing to think about when talking about the caching model. So if you're using the Redis proxy or the Redis database to help ease your traffic load by caching common responses or common queries like credentials and session management, you can actually do a lot of that caching behavior on a container by container basis for your data plane, where they use in-memory caches. The difference in that type of scenario is if you have, say, a rate limiter and you are using in-memory cache, for the data plane, you're going to see those counters specific to each proxy. So if you have a specific counter on a session that is on container A, and then that traffic switches to container B, your counter is going to start over again on that new container as long as the session is running through that other data plane. With Redis, it unifies counters like that so that all sessions, no matter which data plane they are running traffic through, are running on the same counter, and Redis coordinates that across all of the data planes. So that should cover that. Do we need to pause for questions? Let's see.
I do have one question from Prem. Can we push changes in custom plugin via Admin API?
Yes, so that is going to depend on whether or not the changes are changes to the configuration of the custom plugin, or if it is a change to the code of the plugin itself. There are a couple of different ways to get a custom plugin code base into the container, and that's either going to be building a custom container with the plugin, the Lua code built into the container itself, or it's going to be something like a config map in Kubernetes, mounting that Lua code into the container at runtime. Both of those scenarios where you're changing the code of the plugin itself would require replacing the data plane proxies themselves. If you are just updating the configuration of that plugin, so the only thing you're doing is changing the plugin config against the admin API, that's a scenario where you would see a push model to update the data planes, and it would not require a replacement of the data plane proxies. So you wouldn't see any, termination and scheduling of new pods.
Thank you, Kat. That's the only question for now. But please feel free and enter your questions, and Kat will pause again in a few moments.
Sounds great. Okay, so with all of these different moving pieces, what is a real world scenario that we can talk about? This is a simplified view of a real production solution that we came up with for a customer who had a really interesting case that resulted in needing to track multiple identities downstream to understand how to handle and respond and control traffic that was coming into the Kong gateway. So there in the top center focus, you see Kong sitting between all traffic flows. And what it is doing is receiving requests from a partner provider that actually acts as an intermediary between consumers and the upstream product APIs themselves. And what this looked like actually was things like IoT devices for energy efficiency and scheduling intelligently, for, like charging batteries, setting thermostats, things like that. And they would need to understand what the IoT devices were, so who those belonged to, whether they had accounts, whether they had different privileges. But those subscribers, those consumers, were actually subscribed to a downstream third party. And we also needed to understand who that third party was and what types of controls and access that third party was entitled to. So different things like rate limiting, quality of service, and which APIs and what privileges against those APIs that third party and that end user was allowed. So there was a custom plugin need here to actually add, besides just the Auth0, which is the OIDC provider we were using, we also had to add scopes, so role permissions, from an additional internal API. And this was a really fun reason to go ahead, use Kong Gateway, write a simple custom plugin, and slip that plugin in between the OIDC authentication plugin and an OPA, or Open Policy Agent plugin, which would return a Boolean, basically, of true or false, based on the roles and permissions that Auth0 provided, and based on the roles and permissions that the custom internal API provided in headers, to then determine whether the traffic was allowed to go upstream to different APIs. So that is one of the scenarios that I really celebrate a lot when looking at why would I want to write a custom plugin. That might sound like some onus to take on. If you look at the lines of code that we did this in, though, it was, I want to say, about 110, 120. And that includes both the schema file and the custom plugin itself. So it was really neat to see how existing plugins like OIDC and OPA were able to cover most of the functionality we needed, but to augment that with a custom plugin was done quickly and efficiently. And overall, it resulted in a powerful story that gave their API the ability to productize and bill based on different contracts with the third-party providers and the final consumers, and understand all of that context. So basically just recapping what we covered. Actually, one thing I didn't mention, I wanted to get into a little bit more about the scaling and how to determine how many instances you might want of different components of Kong. So let me actually rewind just a little bit to make sure that you can kind of see the developer portal. That is something that you're usually only going to, in a Kubernetes scenario, run 1 or 2 pods of. If you're looking to be really efficient and responsible with the overhead of what you're running, the developer portal can be run as a single instance, a single pod. If you're looking for that HA, that high availability, 2 pods is perfectly reasonable, so that if there is an update to your Kong containers and you have to release a new version of Kong and you want that developer portal to experience no downtime, 2 pods make sense. There's not really, generally speaking, a time when you would need to see that developer portal, which can be deployed as its own pod, scale beyond 2 or 3 pods. The admin GUI is very similar, generally speaking, 1 or 2 pods there, depending on whether you're worried about HA for that uptime. And beyond that starts becoming pretty redundant. The Ingress Controller as well. Really, you don't want to see that scale more than 1 in most scenarios. The Ingress Controller is neat because it pairs 1-to-1 with the Kong workspaces. Those workspaces are a logical separation of different roles and teams that you might constrain. So if you have internal developers and external developers and you want to create different permissions for those different groups, then you might use different workspaces, and that's going to map 1-to-1 to their own individual Ingress controllers for what you're going to see in those different workspaces. And those workspaces are also represented as different developer portals. So you might have an internal developer portal and an external developer portal. The Ingress controller, you're really only going to want 1 instance of it per workspace. If you scale beyond that, you're hitting your Kubernetes API with redundant update queries, and that really doesn't add any value. So 2 Ingress controllers for the same workspace would just double your Kubernetes API workload for the Kong gateway, without adding any value. The data plane, you can conceivably scale infinitely horizontally, so long as never mind, I just lost track. Okay, so your data plane can scale horizontally based on the need of your traffic coming in the door and the availability that you're looking for. So if you're looking for high availability and you're covering all of the traffic that you need and you're not dropping packets, 2 or 3 data planes make sense. If you need to scale that to hundreds, that is a component which can be deployed individually and would make sense to scale. In some deployment scenarios, you might see all of the control plane components and the data plane all lumped together as a single, like Helm release, for example, where all of it lives in the same pod. Scaling that infinitely horizontally would be detrimental to the behavior of your Kubernetes cluster and inefficient with the resources of your cluster as well. So I did want to make sure I hit on that, and I had forgotten to in the middle there when we were on this slide. Other than that, that should pretty much cover everything that I wanted to share today. I hope it was helpful. And if there are any other lingering questions in your mind, I would love the opportunity to speak to those.
Yes, if you have any questions for Kat, go ahead and put them in the chat or the Q&A. While you're thinking, I will just do one last plug for Kong Summit. So we have Kong Summit coming up at the end of September. It is our annual user conference, and we have a couple of great developer events to go along with it. One is our Kong Summit Hackathon, which is a virtual hackathon open the month of September. All contributions will receive a t-shirt, valid contributions, and we're going to have various webinars and Kong Builders episodes throughout the month to help you with your contributions. And then we'll also have awards for the top contributions, for which are large prizes, and even a top award that will be awarded at Kong Summit on stage. So please check that out, register your interest. The forum is not open until September 1st though. And then we also have if you have already made contributions, we're going to have a Contributor of the Year award. So check out our awards page for more details on that. I will add that in the chat. Doesn't look like any questions have come through quite yet. Kat, you must have been very thorough. But we'll hang on here just for a couple more moments to see if there are any last questions. But overall, thanks everyone for attending today, and a special thanks to Kat for her excellent presentation and very screenshotable slides. Those were amazing slides. Reminder to also just check out the Kong community page for more information on Kong open source products and how you can get more involved with the community. Thank you so much everyone for joining, and have a great rest of your day. We hope to see you at a future Kong Tech Talk.